So talking about differential calculus. Differential calculus is a very broad branch of mathematics. About this calculus. There are there were two men named There were two men named Leibniz. One was Leibniz, make it which Leibniz or something, and one was Isaac Newton. This one was from the 16th century to the 17th century, and this one came in the 17th century. So Isaac Newton did some work in his book named The Principia Mathematica. He did the work where he calculus, invented calculus, Isaac Newton. So Leibniz also invented calculus. They said, according to the history, it was said that Leibniz started with integration and Isaac Newton started with differentiation. So Isaac Newton actually claimed that Leibniz actually he, he actually stole his work. He accused Leibniz of plagiarism, that Leibniz stole his work. So that's just that after he published it around 17 something, 1760 something. So then Leibniz got the work and he actually brought something like that out too. But the notions, or is it the notation? Notations rather, sorry. But the notations we'll be using, or that we've been using in the notations we've been using in calculus now are all based on Leibniz work. So he brought out the notations. So Isaac Newton's notation has been dropped. Yeah, they don't use that in the modern days. So let's just enter what we want to do. I won't like to waste our time. When we mention when we mention differentiation exactly means increase in something with time. That means the rate. So calculus differentiation means the rate of change of something. So differentiation means the rate of change of a quantity. That's what differentiation means. The rate of change of a quantity. So now look at the length of a material before was this L1. The next length becomes L2. So increment is known as the change. The change is known as delta L. Please, I've started explaining. The change is known as delta L equals to the increment in the length of the material. Let's say the material is an iron rod. The former length of the iron rod is L1. Now, maybe after it's been heated, there is an A. Was L1, and the new length becomes L2. So the change in the length of the material of that iron rod becomes L2. That is the new length minus L1. So we can just denote it as delta L. So this is delta, one of the Greek alphabets. Delta, one of the Greek alphabets. It is this, just like a small triangle. Delta, one of the Greek alphabets. Calculus. It is of two ways. We have calculus into two ways. We have what is called differentiation, and we have what is called integration. Differentiation calculus. That means calculus of differentiation is known as the differential calculus, while okay, while calculus of integration is known as integral calculus. So we'll be working with differential calculus at the moment, a very, 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 very broad branch of mathematics. Calculus. Calculus is a very broad branch of mathematics. It is really broad, extremely broad. Yeah. So now, when we mention differentiation, when you hear differentiation, just know it is talking about increment. Differentiation means increase in the difference between the original and the new measurement of a particular stuff or quantity. Let's say now I measure the length of a rod, an iron rod. I measure the length to be L1. Now I heat it. After heating, expansion will occur. So it becomes longer. I'm now measuring the second length. So now to measure the change, that means the increment, the differentiation is now L2 minus L1. That means the increment in the length. So this L2 minus L1 is denoted as delta L. Delta L. Delta L means change in the length of the material, of the iron rod, change in the length. So delta, as I said earlier, is a Greek alphabet. This is delta. We have alpha, beta, gamma, psi, rho, pi, omega, and the likes. So this is delta. So delta, this is capital letter of delta. I see it somewhere also like this. Delta L equals L2 minus L1. This is the small letter. So now taking the this stuff now, taking it as the increment, we'll be working with it. The original measurement is 2x squared plus 5x plus 3. So what is the increment in this stuff against x? That means the increment with respect to x. Let me just, okay. I'm thinking of something. Let's start from the first principle. I should be nice. I'll start from the first principle of differentiation. There is piecewise method of continuity and the likes. So, but let me just take it from the first principle. Yeah, I would like to take it from first principle. Okay. Differentiation from the first principle. That exactly means we are using one thing called the first principle. And in this class now, I would really like everyone to be together. This is a polynomial. Y equals 3x squared plus 4x plus 4x minus 5, right? This is just a function of y depending on x, right? This is a function of y depending on x. Or is it not a function? Is it not a function of y? We can determine that by ourselves. I'm very sure of that, according to what we've done. So I believe some of you can determine if y is a function of x. I shouldn't waste my time on that one here and now. So now this y, I can definitely do something to it and find dy dx. That means change in y with respect to x, 4x minus 5 dx with respect to x. Y with respect.
It's freezing at some point, please.
To x.
Exactly, your network is not good.
Got it. Okay. All right, are we together now? Okay, so change, it's the y dx means change in y with respect to x. That's the meaning. Change in y with respect to x. So definitely I can say, look at the d very well. This d I'm talking about is the increment, d of increments. So now it is different from dy of this. So d, you know this y is 3x squared plus 4x minus 5. The y means this polynomial. So d dx, that means delta x of 3x squared plus 4x minus 5. Just using the whole of this to represent the y. So if I have y to be equal to 3x squared, then I can have dy dx to be equal to what I have, right? So I don't want to do any work now. I want us to use the first principle first. So now I can now say d dx of 3x squared. Instead of writing dy, so it will now be d 3x squared dx. Instead of writing dy dx. So as usual, please show with emoji if you understood what happened. Please show with emoji. Okay, I have to come back. Two people got it. I have to come back then. I have to come back then. Who's it? Next he's going to owe you. Okay, as I was saying, yeah, this is what I'm trying to.
Stop playing.
So this is what I'm trying to. Jeffrey, I don't miss you. I lie. I swear, I don't miss you. So this is what I'm trying to plot out. We said y is this polynomial, right? Y equals 3x squared plus 4x minus 5. So dy dx means change in y with respect to x. That's what we call it. We call it dy dx. That's why I wrote it here. Dy dx. So it means the change in this y, this is y, change in y with respect to x that is inside it. You know y depends on x here now. Y is the dependent variable. X is the independent variable. So now dy dx equals d of the x. D dx, you know this y, d dx, this y, I can as well write it as the whole of this and say, instead of writing dy, I'll just write it as d, and what is y? 3x squared plus 4x minus 5. It will now be the whole of this. It will now be d dx, 3x squared plus 4x minus 5. So now I'm using this one to be a simpler method to explain it. I have y to be 3x squared. The y is exactly the same as writing d, what is y? 3x squared dx. So if you have y to be 4x, you are asked to find dy dx. Don't be confused that they might also bring it as find d of 4x dx. Why? Because 4x represents y and y represents 4x. That is the meaning. So did we get it now? Okay, that's fine then. Fine then. That's fine. So let us work from the first principle. Differentiation from the first principle. That's our work. That's our first work tonight. I'd like us to do. Calculus is a very interesting topic. I love teaching it in class. Very, very interesting. So differentiation from the first principle. Yeah, we have to move very well together, guys. It shouldn't be just a person. We're all working together. Why we started? We are going to differentiate y equals x squared from the first principle. I'm very sure many of us can differentiate this one fast without any fucking first principle. And we all believe it's going to be 2x. Right? I'm very sure of that. It's not even right. Yeah, I'm very, very sure. I have many people here that I'm quite sure that they will do it now. So, but let's start from the first principle, from the simple way to the ln. to the hard way. We keep taking it from simple to complex. Helen, do you have anything to say? Helen. Okay.
Yeah, I can't really, the network like it's really, really bad, so I can't really see what you're doing in the water. So.
It's from your own network, Helen.
Oh,
Helen,
yeah, no, yeah. Oh, yeah.
Helen, it's your network. Please welcome us. I wish you the best.
Right. All right. Thank you.
Starting from the first principle now, I'm saying y equals x squared. The first thing is to bring increments in y. Bring it. So y plus dy. I'm using capital letter here. Don't be confused. In some textbook, they will use small letter delta. So y plus dy. So y plus dy equals. So since you already changed what your y is, you are using the both of them to represent y. Because what? This is y. This is y plus dy. They give you this y increment. I don't want to be explaining that too. Like maybe some people will not understand, and I don't want to make things more complex. I would have explained how it comes to y plus dy. So we are using y plus dy to represent ordinary y here now. So y plus dy equals x plus dx squared. What just happened? I used y plus dy to represent y, and I used x plus dx to represent x. So if I'm differentiating from the first principle, anywhere I see x from the start, I'm going to use x plus dx to represent it. And anywhere I see y from the start, I'm using y plus dy to represent it. Please, with an emoji, if you understood that. Perfect. I don't want us to go far before people start saying I'm having issue. Yeah, I wish everyone the best. I hope everyone understands it at the end of the day. Very well. So now we still have y plus dy equals, we are going to expand this bracket. So I said I won't be working alone. Miss Joy, please do the work for us. X plus the x squared. Expand it for us, please. Amuche Joy.
So it's going to be x plus dx into bracket x plus dx. X.
Yeah. I don't want us to be writing that out again. Simplify it somewhere and tell me the answer, please. You get it?
I beg, write it out. I beg, write it out.
No, we are not supposed to be writing it out, Mabi. X plus dx. To be sincere, you don't need to write it out at all. We are only expanding. This one, I'll still rub it up and write the expanded form. This is what we are doing, everyone, right? So let us expand it together because of everyone. That's a good idea. I'll rub it up. So x times x gives x squared. And x times dx gives x dx, everyone. Plus dx times x give x dx again, plus the x times dx gives the x squared. Look at my bracket. Please note how it is written. The x times the x gives the x squared. The x times the x gives the x squared. So I have x squared plus x plus the x plus x plus the x gives 2x dx. X dx plus x dx rather gives 2x dx. So plus the x squared. So this is what we have as the expanded form of this thing. So I'm going to rub this off. This is what you go and do something here. No lecturer will need this from you. X squared plus 2x dx plus the x squared. Please, are we all getting it? I would really like you to show with an emoji if it's not moving fine, please. Before we go far, thank you. Thank you. Now remember one thing, that y is here. What are we looking for? We are differentiating x squared from the first principle. What is the differentiated form? It's going to be in dy dx, right? So we are looking for dy dx. So we take y from this point to the other side. It becomes negative y. So dy equals x squared plus 2x dx plus dx squared minus y. Because we brought this y away from this side, it comes to this side. This is the first principle, a very simple method. By the next example, you understand it better. So minus y. So this is now x squared plus 2x dx plus dx squared minus, what is y from the start? Come and take what y is from the start. Y is x squared from the beginning, right? So minus x squared. Here now, I'm already having x squared here and having minus x squared here. They cancel each other to give 0. Is x squared minus x squared 0? What do I have left? I have dy equals 2x dx. Please just react now before we go too far. If you don't understand, plus dx squared. All right. Fine with this. Now, the next thing is just to divide both sides by dx. Divide through by dx. Divide through by delta x. To divide through by delta x, that's dy over dx. You can see we are getting dy dx already. Dy over dx equals 2x dx over that dx. Don't forget, we are dividing through by dx. Plus dx squared over dx. Okay. So dy dx is it raising? Okay, Jeff.
I thought that if you are to divide both sides by the x, the second side is going to be 2x dx plus the x squared all over the x. Or are you dividing 2x dx differently from the x squared?
I'm splitting it straight. Since we'll still have to split it, it's like 1 over 2 plus 1 over 2. It's the same as 1 plus 1 over 2. That's why.
Okay.
So I'm just splitting it straight. So we are still going to cancel. That's why I'm splitting it straight. This dx, we cancel this dx now, right? And this dx cancels the square of this one. Square means 2 dx that are there. This is where limit now works. That's why you study limit before calculus. We have 2x, no more dx here, plus dx. This dx that is there. Now, you now come here and write limit dx to 0. Limit dx to 0. I will now have dy dx equals 2x plus, what is dx? 0. So dy dx equals 2x. That is the final. Yeah, sad emoji. Sad emoji.
Wahala.
Na him be real wahala.
Abeg, where limit the x to 0? Where you from bring that one? Where you from bring that principle?
Please repeat that, beg.
Don't forget that.
I was thinking that we are the x square. It's just supposed to cancel 1 and leave 1. Why is it cancelling the square?
It is the one that is cancelling now. It's the same thing now.
It's the same thing now.
It's the same thing that happened or that happens there. So Jeffrey, we've actually treated limits. I've said it that I don't miss yourself. Say no, they did. So the limits here now. This is from the first principle. You limit the x to 0 at the end of the day. After dividing through by dx, you limit the x to 0 at the end of the day.
Okay.
We mentioned it at the first principle. It's a principle. It has its own way. So that's just it. By limiting the x to 0, that means you are using 0 to represent the x. So now I have dy dx equals to 2x plus 0, which apparently gives me 2x. We are going to take the next example and basically understand. And I believe it will be fine to understand. I'm coming. Okay, please, if you are going to make a screenshot, I want to take another one. Okay, have we made the screenshot? Okay. All right, I'm going to rub this up now and do a more interesting one. What we are going to have now is differentiate from the first principle. Y equals 4x squared. More interesting. It's a handsome question. Y equals 4x squared. This is definitely 8x at the end of the day. So don't forget that I said the first step in the first principle is to represent y with what? Who's going to answer us, please? Represent y with what? Anyone, please, just raise your hand straight and talk.
Y plus dy.
Thank you very much.
plus dy.
I'm going to follow you, please. Y plus dy. Let me use capital letter delta here now. Y plus dy equals. So, and I said x will be represented by what? So, not delta.
X plus dy.
X plus
X plus
dx dx.
x plus d. X squared. Close the bracket back. 4 is still here. Don't forget. Please show its reaction. Are we moving? I really don't want anyone to be left behind.
Please, no, please. Your line was breaking before. I don't know.
Okay, it's not my line, it's your line. So I said we are going to expand x plus the x. To expand that, we know, right? We should have x squared plus 2x dx plus the x squared. Don't forget that the 4 is still out. This is the 4, and the bracket still does its work. Its work, rather. So now, y plus dy equals, let's expand this bracket now. Is there anyone that can volunteer to go with it, with me for it? Let's expand the bracket.
Yeah,
Okay,
yeah.
GOH. So that is what?
4x squared
Expand. Okay.
plus
Okay.
8x dx
Perfect.
plus
Okay.
4 delta x squared.
Yeah. Thank you very much. Thank you very much. So we've expanded that. That is very good. The function given was y equals 4x squared. Now, the first thing we are going to do, one of you even mentioned it, like we're going to represent this y using y plus dy. We are going to represent y using y plus dy. So y plus dy and represent x using x plus dx. Do not be carried away by anything. Your expression still stands the way it is. Just that you are using x plus dx to represent this x. Instead of this y now, I'm writing y plus dy. That means the y and the increment y. The 4y and the increment in y. This is your unit y. This is what I didn't want to explain before. I don't want to confuse people. And then 4 is here, right? Multiplied by x plus the x, which is representing this x. Don't forget the square that is on it. Matter can neither be created nor destroyed. Do not forget the square. So y plus dy again equals 4 times, we are going to expand this, right? So by expanding it, we have x plus 2x dx plus the x all square. Don't forget that the 4 is outside the bracket. The 4 is outside the bracket. So now expand it, open the bracket now. I'm going to have 4x squared plus 8x dx. That's 4 times 2x. Okay, Joy.
I'm going to ask at the end of the question. Just continue.
Okay. So 4 times 2x squared, that's 8x plus 4 times the x squared, that's 4x squared. So now we have this already. 4x squared plus this. He said we need the y x to be found. Right? This is y. We have to take it to the side. And taking it to the other side, it becomes
Equal
negative.
minus.
Let's mute our mics, please. So it becomes negative y. So dy equals 4x squared plus 8x dx plus 4 dx squared minus 4x, because the y is what? 4x squared minus 4x squared. And I want you to remember that 4x squared is here minus 4x squared is here. It's the same thing as having 4x squared minus 4x squared. Apparently gives 0, right? So dy dx equals 8x dx. That means dividing both sides by the x, dividing through by the x. So dy dx equals 8x dx all over the x plus all the x squared over the x. The x cancels the x here, the x cancels the square here. So we have dy dx equals 8x plus 4 dx. So now dy dx equals 8x plus 4 times 0 when you limit the x to 0. You limit the x to 0. So 4 times 0, 8x plus 4 times 0 gives 0. So the y dx equals 8x. This is the second time I explained it now. So please, Joy, what's your question? I won't
Okay,
say, do
thank
you
you so
understand?
much. I clearly understand, and even while you left, some of us have already started solving it. So, but my question is it always, is the limit always zero?
Yes, from the first
It's
principle.
always
The limit
zero.
is 0. Yeah, when using the first principle, the limit is always 0. You limit the x to 0 at all instances. You get that? Okay. All right, then
Yes, we get it. Yes, we get it.
okay. Let's take one more example. I'm going to use 4x squared minus 3 now. I'm going to, please don't be confused though. I'm going to change the way again. I have 4 f of x. I'm going to write the question out this time around. Let's say this is the question. F of x equals, if f of x equals 4x, let me use 2x squared minus 3. Find, please look at what I'm going to write very well. F prime of x. F prime of x means the derivative of x. The derivative of x. Derivative of x means after you derive it, what did you get? That means the differentiation. It only means differentiate f of x. Differentiate f of x. That is the meaning. You are given f of x. That means like you are given y equals to 2x squared minus 3. Find y prime. You are given y to 2x squared minus 3. I'm giving you in the several ways it might come from textbook as I'm remembering it. So y prime equal to y dx is also equal to the 2x squared minus 3 dx. Please, do you understand what I did here? If you want me to explain this thing I wrote here again, I will do, please.
Explain again, I beg.
Please explain.
Explain.
I said y is given to the 2x squared minus X plus the x. So x plus the x. Don't forget this square here. Squared minus 3. Do you see what is happening now? I did not put everything inside. I don't yet to explain everything. This is what I'm trying to show you. 2 times x plus the x squared minus 3. Please don't put on anything.
Sorry, the minus 3 is not having x or the x.
Because it's not having x, that means there's nothing I can do to it. You get it now? Do you get it, Nneka?
Yes, yes, because it doesn't have any x attached to it. That's why.
So y plus y equals 2 times, expanding this one now, I'm going to have x squared plus 2x dx plus dx squared minus this 3 that is here. Don't forget. This one is against this bracket, so I must open the bracket. 2 times x squared gives 2x squared. 2 times 2x dx gives 4x dx, and 2 times the x squared gives 2 the x squared. Don't forget minus 2. So now bring y from this place to the other side. So dy equals y becomes minus y there, right? 2x squared plus 4x dx plus 2 dx squared minus 3 minus y. That is minus what is y? Who remind me what y is? I'll tell you soon.
2x squared.
2x squared minus 3. Don't forget. You can put the minus y. Please note it very well. Minus is before it, and I'll put bracket. Please don't make any mistake in that sense. So I have 2x squared plus 4x dx plus 2 times dx squared minus 3 minus 2x squared. That is minus times this. And minus times minus gives plus. That is minus times minus plus 3. Now, come and look at something. I said one thing happened earlier, and that thing will keep happening until you finish using first principle. That is 2x squared is here. 2 minus 2x squared is here. They cancel each other. Minus 3 is here. Plus 3 is here. Get that? So now, delta y. All right, all right. You can see that some people got what actually happened. So delta y equals 4x dx plus 2 dx. This is what I have left. Yeah, this is what I have.
Plus 2 dx square.
Sorry. Yeah. This is the x cancels the x here. The x cancels the square here. If it is cube, it happens too. So I have dy dx to be 4x plus 2 dx. Now limit the x to 0. Then dy dx is going to be 4x plus 2 times x. That is the derivative of f of x. So I will now write it as f prime of x equals 4x. So f prime of x means dy dx. Aminat, let's hear you.
Yeah, sorry. Please, can you hear me?
Can I what?
Can you hear me?
Yes.
Please, if this one came out in exam, like, you know that our exam is objective, are we going to do it this way or we use shortcuts?
You use shortcuts, you know. You just something I will do without. I will even do it in a fraction of a second.
Because I use shortcuts to get answer directly, and I don't know whether the rest can use shortcuts. If you can help us do it.
Yes, now we'll do it, but now I can't just, since we are passing through the course, we are not actually reading only for exam. That's why I'm explaining all this. Since it's not
Okay.
exam period, how do you now? You get it? It's not
Okay.
exam period.
Thank you.
We are really going to get there. We will explain all the laws in this one, all those product rule, quotient rule, chain rule, function of a function, the likes. So let's just be
Okay.
moving like
I beg, all those shortcuts go make sense. So
Now there they see you.
yes.
There's no shortcut to success.
Short dog will make sense, but remember that knowing this one too is fine. You will never use this one in exam. I'm very sure.
yeah, for sure. Very soon.
Plus 5x plus 5. Here's where please move. This is what's actually happening here. I said there is actually a formula, and the formula is in form ax raised to the power of n. So the derivative, if y is this, the derivative of y will be an x raised to the power of n minus 1. For those of you that could capture that, if not, listen to this. We are using this 2, which is the power, to multiply the coefficient of that x. 2 times 2, Kingsmate, that is 6x raised to the power of, you now do 2 minus 1, that power minus 1 raised to the power of 1. That's ordinary 6x. Plus 5 times, just forget this one. Don't do any calculation, 5, because it is just 1x. The next one is y equals 2x cubed plus 5x minus 5. My mind don't really be here again. So I won't be explaining as I explained earlier. So
That will be
2 times
6x.
3x, that's 6x raised to the power of minus 1, 2 plus 5. Y, so this one is dy dx. So y equals 9x cubed plus 5x minus 5x plus 4. So 3 times 9, 27. X raised to the power 3 minus 1 again, 2 plus 2 times 5, 10.
10x.
Minus 1, 1. So that's dx. Now y equals 19x squared minus 9x plus 4. So dy dx equals 2 times 19, 38.
38.
X minus 1, that's ordinary 1, minus
Minus 9.
So everyone, thanks so much for your time. Thanks for everything. I really appreciate Mr. Edwin, I appreciate you so much. The sub is more than what I can use in this class. So I really Jeffrey, I really appreciate you very much. I mean that.
You did not appreciate me, Abby.
I appreciate you all, sir. I appreciate you, Mr. Ime. I appreciate everyone.
Ime, you are